Our own world, Earth, teems with an astonishing variety of life, from the smallest microbe to the largest whale. But what if we were to look beyond our blue planet, out into the vastness of space? The universe is unimaginably large, with countless stars, and we now know even more planets. It seems almost inevitable that life in some form has taken root elsewhere. Imagine for a moment worlds utterly unlike our own. Planets bathed in the dim glow of a red dwarf star, or gas giants with atmospheres that stretch for thousands of miles. In this journey we shall explore three such hypothetical worlds born from scientific understanding and imaginative leaps. Let us open our minds to the possibilities that lie hidden in the starlight. Our first destination is a planet named Iper, a world that orbits a rather dim star called Oculus. Because Oculus provides so little warmth and light, Iper must huddle incredibly close to it, orbiting about 20 times nearer than Earth does to our Sun. This proximity creates a unique environment. This intimate dance has a profound consequence for Iper. It is tidally locked. The side of Iper facing Oculus is not uniformly warm. Instead, it experiences a gradient of temperatures. Much of it is still frozen, but there is a special region, a vast area where the star's faint energy has managed to melt the ice. This creates a unique ecosystem. Here a shallow sea has formed, known as the Black Ocean. This sea is teeming with potential for life. The boundary of this warm zone is a place of constant turmoil, where ice meets water in a dynamic dance. The light that reaches the surface of Iper, even on its day-lit side, is predominantly weak infrared light. This light is just enough to sustain some forms of life. Iper, therefore, presents a fascinating case study in how life might evolve under conditions far removed from our own familiar terrestrial experience. It challenges our understanding of habitability. Descending beneath the surface of Iper's Black Ocean, we would find an ecosystem uniquely adapted to the faint infrared glow of Oculus. Instead of green forests, imagine vast underwater jungles composed of plants that are deep black. These plants anchor themselves firmly in the muddy seabed, drawing nutrients and providing vital shelter for other creatures. Amongst the swaying black fronds, a variety of animal life has evolved. Fish-like grazers with streamlined, teardrop-shaped bodies move efficiently through the water, their forms optimized to reduce drag as they feed upon the abundant black plants. Predation is, of course, a constant pressure in any ecosystem. Here in the Black Ocean, a cunning hunter has evolved a remarkable form of camouflage. The inhabitants of this ocean communicate in ways suited to their dark environment. It is a world alive with textures and sounds, a rich tapestry of life hidden beneath the waves. Section 4, Nimbus, a gas giant adrift in the blaze of a hot star. Our next voyage takes us to a very different celestial body, a gas giant named Nimbus. This colossal planet orbits a star called Koulous, which is a stark contrast to Iper's dim Oculus. Koulous is a B-type star, meaning it is incredibly hot and brilliantly luminous, far brighter and more massive than our Sun. Nimbus is a world without a solid surface, much like Neptune in our own solar system. It is primarily composed of gases with an abundance of water in its atmospheric layers. Life on Nimbus did not begin in these upper, more temperate layers. The journey of life from the depths to the upper atmosphere of Nimbus is a remarkable tale of adaptation. Section 5, Life Aloft, the aerial ballet of Nimbus. The foundation of Nimbus's extraordinary aerial ecosystem is formed by quadrillions of tiny beings known collectively as cloud plankton. These minute creatures, often just a millimeter in size, are typically white with a yellowish tint. Many resemble flat, four-legged spiders. Their existence is a marvel of adaptation as they have mastered the art of buoyancy. These cloud plankton are not merely passive drifters, they have a complex life cycle. For reproduction, they gather in immense numbers, forming colossal parachute-like structures. Dominating the skies of Nimbus are the sky whales, truly enormous creatures, taller than any skyscraper on Earth. Sky whales feed by unfurling a vast sticky net many kilometers wide to filter the cloud plankton from the air. However, these majestic creatures are not without their own challenges. Evolutionary cousins, known as jet squids, which are roughly frog-sized, often trail them. Section 6, Monnier, a moon bathed in aurora orbiting a failed star. Our final destination is Monnier, a moon with an environment shaped by truly exotic forces. This moon is unlike any other we've encountered, with its unique geological features and alien landscape. Monnier orbits a celestial body named Orad, which is not quite a star but a brown dwarf. This failed star provides a unique backdrop for Monnier's extraordinary environment. Orad possesses an incredibly powerful magnetic field, 60 times stronger than Jupiter's, and its system originated from a nebula rich in heavy metals, including lead. This intense magnetism influences everything on Monnier. Monnier circles Orad at an astonishing speed, completing an orbit every 3 hours. This rapid orbit creates unique day and night cycles, adding to the moon's mystique. The gravity on Monnier is also remarkably weak, only 5% of that on Earth's moon, meaning even small forces can have significant effects. This low-gravity environment makes it a fascinating place for scientific study. Monnier has a thin atmosphere, capable of holding some carbon dioxide, but it doesn't retain it very well, leading to a tenuous gaseous envelope. This thin atmosphere contributes to the moon's harsh and cold conditions. Despite the cold and the rapid days, Monnier's landscape is dramatically illuminated. The interplay of light and shadow creates a surreal and otherworldly scene. A constant, vibrant green aurora shimmers across its sky. This aurora is a result of the intense magnetic activity from Orad, painting the sky with mesmerizing lights. Life here has had to adapt not only to the extreme cold and potential toxicity from heavy metals, but also to utilize unique resources like ammonia and the pervasive magnetism. These adaptations make Monnier a unique and intriguing place for studying extremophiles. Section 7: Monnier's Magnetic Marvels and the Universe's Endless Song. The Arctic flowers of Monnier possess a truly astonishing adaptation. These flowers are not just beautiful, they are a testament to the incredible resilience and adaptability of life in the harshest conditions. Their delicate blossoms are saturated with magnetic minerals drawn from Monnier's metal-rich crust. This unique feature gives them a shimmering, metallic sheen that is both mesmerizing and functional. Due to the moon's extremely low gravity and the powerful magnetic fields generated by Orad and influencing Monnier, these flowers can achieve something remarkable. They levitate. This levitation is not just a spectacle, it plays a crucial role in their pollination process. Sharing this bizarre landscape are the shiny skaters, fast-moving creatures with 2 distinct stalks. These creatures are a marvel of evolutionary engineering, perfectly adapted to their magnetic environment. When they need to travel, these stalks merge to form a kite-like shape. This transformation is not just for show, it is a sophisticated method of locomotion. This structure isn't for catching wind, but rather for interacting with the magnetic fields. By doing so, they can glide effortlessly across the terrain, conserving energy and evading predators. The shiny skaters are not alone in their ingenuity. They engage in a fascinating symbiotic relationship. This relationship is a delicate balance, showcasing the interconnectedness of life on Monnier. The apex predator of this cryomagnetic ecosystem is a creature that resembles a strange fusion of a lion and a beetle. This formidable predator is a key player in maintaining the balance of this unique ecosystem. Such worlds, Ypres, Nimbus, and Monnier, stretch our imagination, yet they remind us that the universe's capacity for creating diverse life may be far greater than we can currently conceive, an endless song of evolution playing out across the cosmos. Each world, with its unique life forms and ecosystems, adds a new verse to this cosmic symphony.